Okay, so this is a review of parabola and quadratic equations. And you guys should be very familiar from Algebra 2, certainly. When we see one, we should recognize one. We should automatically think in our mind, what's the shape? And what shape are we thinking about? A U shape, roughly speaking. Either pointed up, pointed down. And by the pointing up, we call convex. Pointing down, we call concave. So given a function, we should also be able to sketch it out so we can go into a little bit more depth in analyzing what's happening in the function. Well, the first thing to plot are the axis-intercept, the y-intercept, right? I mean, the y-intercept is when x equals 0. So that's our y-intercept right there. And of course, a nice thing on a graph that has no scale on it, you get to pick the scale. And guess what? Negative 20 is right there, exactly. And then the other key points on a parabola would be the x-intercepts and also the vertex. So how do you find the x-intercept? How do you find the vertex? All right, so we set y equal to 0 because when our y equals to 0, we're down at this level. We're down at the level of the x-axis, right? So by setting y equal to 0, now we're looking for y values that are 0 that make this equation true, and we'll get any points that pass through that axis. How many points could we get? Now, is this pointed up or down, first of all? Look at this. That tells us, right? Positive means that we're convex, we're holding water, right? And a negative leading coefficient would be concave. So we know this is convex. And we know that one's at negative 20. So we have to at least pass down through this and come up again. I mean, typically we'd expect this to happen, something like this. But generally speaking, do we always get two intercepts? I mean, we could get one intercept. How? Concave. If it was concave in this case and did what? The vertex was on our axis, our x-axis. And if we had no hits, what would it look like? If we shifted this down a little bit, so if we had a parabola that never hit, we'd have no intercepts. All right. So there are three cases. We have no intercepts, one intercept, or two intercepts. All right. So let's go back to where we start here, and we'll throw our point of 20 back in, negative 20. And we'd expect this to have two solutions, right? Because if this thing's going up, well, we've got to hit this. We've got to be going up. We've got to hit the x-axis sometime. So we'd expect that we'd get two solutions for this, for the x-intercepts. And to find the x-intercepts are found when y equals 0. All right. So these x values, when we solve, will get us our x-intercepts, x-ints. How do you solve that? Factoring is something, hopefully you enjoy factoring. I like to factor things. In physics, unfortunately, we don't tend to use numbers that are these nice round numbers here. We use numbers that occur in the real world. So the likelihood that you'll actually be able to factor something is very low, all right, without using a tool at least. And you'll see what the tool is in a minute. So 0, yeah, I mean, exactly, something, right? So how do I factor this particular one using our factoring skills? Well, 2x in an x will give us your 2x squared. Plus 8. Well, 20 times 1, 10 times 2, right? 5 times 4. And we're looking for twice of one of these times one of the other. And I'm going to, since these are negative, I'm going to take a difference of those should get us a negative 3, which is a... Which one? Plus 5, 2x plus 5. So we get 2 times 5 is 10, and a 1 times 4, or the other way around? 2 times 4 is 8, and a 5. 8 and a 5 is a 3 difference, right? So we need to have twice of 4, right? So if I have a 4 over here to get 2 times 4 in our outside terms, and I have a 1 right here, I'm sorry, a 5 right here. One is going to be positive, one's going to be negative because we have a negative sign right here. All right, and we need the ultimate value to be negative 3x. So our inside terms gives us 5x, our outside terms is 8x. And so we want our outside terms to be negative to make this negative. How do you check that? FOIL that out, right? So let's just double check it, make sure. Oh, wait. So we get 2x squared. That's our first. Our outside is going to be negative 8x. Our inside is going to be positive 5x. And our left is going to be negative 20. You're kidding me, right? What happened on my screen? They hacked into my Acer. I cannot believe this.
Is the bulb going?
All right, so we found that these are our factors. What do we do with these factors to find our zero set? We can set, if either one of these factors is 0, that would make the whole equation to be 0 to match the other side, right? So we'll have an identity. And that's how that process works. We can't do this if there's a 1 or something non-zero over here. It only works because of the properties of 0 in multiplication, all right? So the key idea here is in order to do this factoring process, we have to have it set to 0, all right? That's the critical idea that people miss. So we have 2x plus 5 equals 0. When we solve that, we get x equals negative 5 halves or negative 2.5. And in physics, we tend to use decimals, not fractions, even though I like fractions, and sometimes it's nice to express things as fractions. And for the second solution, we have x minus 4 equals 0. So we have x equals positive 4. All right. So I am going to plot positive 4, which is exactly right here on my graph. But now I'm establishing a scale. Unfortunately, I can't hide anymore. All right, and so 2.5, negative 2.5 is right there. All right, where's our vertex going to be? I mean, that's enough. 3 points are enough to draw a parabola, right? All we need is the minimum number of points we need to draw a parabola is 3. So we have enough. There's like one parabola that fits with those 3 points. That's it. Our vertex is going to be somewhere over here. How do we get that value?
It's 0.75.
How do you know?
You take 4 and 2.5, and you get the middle of them.
I mean, yeah, what we have here, what am I drawing here?
Imaginary line. Dotted line.
That's my line of symmetry, because this is a symmetric function. It's an even function, if you remember what even functions are. And our line of symmetry is going to be halfway between our points. Any two any 2 points where we draw our vertical line, our horizontal line through. So I can take any let's see. So I can take. So we're going to take our 2x intercepts. We can just take the midpoint of those, and that will be where our line of symmetry is. So we can actually average. So if we take a positive 4 and a minus 2.5, and if we divide by 2, we're going to get our x-intercept. I mean our vertex value of x. And 4 minus 2.5 is 1.5 divided by 2 is positive 0.75. And my sketch here had hit a pretty good position, right? So we know that's 0.75. What's the y value?
Oh, you plug.
We can plug 0.75 right into our equation. This might be a good time to use fractions. I like rather than decimals. Minus 3 times 3/4. Put 3 there. Minus 20. 3/4 squared is what? 9/16 times 2 is 18/16. Minus 3/4 times 3 is minus 9/4. Let's convert that to sixteenths real quick. How many sixteenths is that going to be? So we're going to multiply top and bottom by 4. So we get 36 sixteenths there. Minus 20. All right. 18 minus 36 is what? It's 18. So it's negative 18 sixteenths minus 20. We can reduce this. So what do we have? That's going to be 9/8, which is what? Which would be 1 1/8. So I'm going to have it negative 21 1/8. And as a decimal, negative 21.125. Yep. All right. So I mean, working with fractions, I like this better working with fractions than decimals. So I like fractions sometimes. Actually, I like fractions most of the time, to tell you the truth. If you're good with fractions, that's a good thing. All right. So there we go. All right. What's another way we could have found the zeros? What if it didn't factor?
The quadratic formula.
All right, quadratic formula. The quadratic equation, should I say? This is a quadratic formula we have up here. The quadratic equation is used to actually sort of brute force factoring any type of quadratic formula that you have, or any type of quadratic second degree polynomial. So the quadratic equation is, well, what is a quadratic equation? It's, so if we have an equation, y equals ax squared plus bx plus c, that's a general formula for a parabola, or second degree polynomial. If we set it equal to 0, and then if we were to solve for the values of x, right? If we were to solve for x now, we'd come up with what? Negative b plus or minus. All right, and you need to know that. All right, so you should know that off the top of your head. So that will solve anything, any one of these. It doesn't matter if it is factorable or not. We'll come up with the answer. So let's just double check to see if it works. And I also want you to practice using your calculator properly. You've got these fancy calculators that have parentheses on it, and better yet, you have these new TI-80s, 84s and higher. They have operating systems that will automatically set up your order of operations for you. I have an older operating system, so I like the old-fashioned way of doing things with parentheses. So for this problem, we're going to start by subtracting 25 from both sides. And we get 0 equals negative 16t squared plus 44t minus 18. Now, you might be able to divide out, for example, a 2 or a 4 out of here, or a 2 at least, if you could divide out of here to simplify this a little bit. But since these are such large numbers and typically things don't factor, I'm just going to go through and run it through the quadratic equation. There's my A, there's my B, there's my C. So when you solve this problem, your two answers, for the negative side, you get 2.25. For the positive side of this, you get 0.5. And perhaps we're in seconds here for time units, who knows. This is an interesting result because if you look at these are nice round numbers, and that really indicates that you could have factored this problem. It would have come out to be some nice factors. So let's take a look at the last problem then. The last problem is similar. Instead of having a 25 out front, we have 50. And so we're going to do the same process. We'll subtract 50 from both sides this time. And once again, we'll throw it in the quadratic equation. All right, so our B is 44. So we're going to get negative B, negative 44. And our A is negative 16, our C is negative 43, all over 2 times negative 16. And once again, to stay out of trouble on your calculator, you need this order of operations enforced. And if we type these numbers in, I'm going to just edit my last result. Just change my negative 18 to a negative 43. And I hit enter. And I get, here's what my calculator says. Error, non-real answer. And what that means is that if you look at this, what would cause this not to be real? Well, if it's imaginary. And what would be imaginary? If we had this quantity that's underneath our radical, this is called the discriminant, is less than 0. And of course, if the discriminant is less than 0, that means we can't get any real answers. What does that physically mean for this parabola? Now this parabola, we have a negative out front here, and so this is going to be opening downward. So our parabola, remember, could be one of 3 options. We could have 2 solutions, one solution, sorry, that should be one solution. Or in this case where we have no real answers, that just means we don't even cross the t-axis in order to get ourselves our 2 intercepts. And so when you get error, non-real answer, well, double check your work first of all to make sure all your numbers are plugged in up here. But otherwise, you should take a look at this, and you can check the discriminant. For example, the discriminant test, if it's less than 0, that means you don't have any real answers. So you might want to go back to your problem, make sure you're doing the problem right in that case, if you're in a physics problem requiring this math.